In this next module, we're going to talk about flow. This is one of my favorite topics. When you talk about lean manufacturing, really it boils down to flow and building everything just in time. So if you're ready to improve on-time delivery, lower your cost per unit, and make more money, these modules about flow are going to help you do all of that, and we're going to do it right now. The secret to running a manufacturing line, a hospital, or any business is to create good flow. That's exactly what we're going to cover in this module. This is part of the improve phase of the DMAIC process, but these steps that you're going to learn, you can apply anywhere, anytime that you need to improve process flow, get better on-time delivery, and reduce your cost per unit. Let me show you an example of great flow.
The Visa check card. Because money shouldn't slow you down. Life takes faster money. Life takes Visa.
Okay, that's an awesome little video. What do you notice about the flow in that process? Well, number one, everybody is doing their job. They know their job, know exactly what they're supposed to be doing, and they are cruising at it. They are clearly well trained in their position. Second, do you notice the song going on in the background? There is a rhythm going on. Everybody is producing exactly what they need just in time to the beat. Well, that is what we want our manufacturing lines to look like. It's what we want our business to look like. Any process that we're running in our business, we want it to flow. If you can create good flow in your process, you're going to improve your throughput. You're going to lower your labor costs, your material costs. And best of all, you're going to improve on-time delivery so your customers are going to be happier. If you don't have good flow, you're going to have delays in your orders. It's going to cost you more money to produce your parts, and you're going to have quality problems. In fact, if you create good flow, you will eliminate all of the waste. Every single waste that you are experiencing is likely caused by having poor flow. My good buddy Ryan recently worked on a project where they were really struggling with quality, and it turned out that their quality was a function of poor flow. The parts were sitting around the factory for too long, getting beat up, having issues due to aging, and so if they improved the flow, it was going to actually improve the quality, and that's exactly what they did. As you'll see in the slides and modules that are coming, flow improves everything. When you think of the word flow, you think about keeping things busy, keeping things moving. But in a manufacturing environment, what exactly do we want to keep busy and keep moving? There are several choices. First of all, you could try to keep your people busy. After all, you're paying them a good hourly wage. They better be busy working on something, right? Maybe it's your equipment. We got to keep that equipment busy. We just spent $1 million on that piece of equipment. We can't afford for it to go down, so we've got to keep it running. Well, actually, both of those are the wrong answer, and I'll tell you why. Keeping your people busy is just a cost. Keeping your equipment busy is just a cost. Where do you make your money? You make your money with your parts or the product that you are producing. That is the only thing that you should care about keeping busy. When I walk into a factory, if I look around and I see people busy, machines busy, doesn't matter to me. What I care about is, can I see the parts moving? Can I see them moving through the process? If I see piles of material everywhere and people are still running around like crazy, like they're busy making stuff, doesn't matter. I know that factory is running inefficiently and that their cost per unit is way higher than it needs to be, simply because the parts are sitting and waiting and not moving forward. So to maximize your throughput, you need to make sure parts are flowing from one step to the next with minimal or no delay between value-added processing. The objective is to keep the parts and nothing else busy. Focusing on keeping people or the equipment busy can really hurt you. In a little bit, I'm going to tell you about a time we were working with a client who was manufacturing these plastic parts called the dead ends. And all the owner of the business wanted to do was keep this one forming machine moving. He was so worried about that piece of equipment going down. As a result, he was constantly overbuilding, which led to massive inefficiencies in his production line, which was costing him a ton of money. He was focused on the equipment, not on the parts. If you think of flow as a river coming down the hill from the top of the mountain, as it's flowing, it's picking up speed, there's more value being added, but then along the way, some things get in the way of the river. There's some rocks of excess processing and difficult tasks that slow the river down. There maybe is a dam where there's a bottleneck and all of the water, the inventory, the products are piling up behind that bottleneck. You might have different pools of inventory in process along the way where people are batch processing or moving things from one functional step to the next in carts or on pallets or something like that. And then there's always eddies of defects and reworks where parts are having to go backwards in the process to get reworked and fixed and adjusted to make up for an imperfect process. If we could eliminate all of that waste from the process, what if we could just take it all out and the product moved from one value-added step to the next every time without having to stop? Think about how much money that would save us. Think about what that would do to our on-time delivery. It would have a massive impact. So I'm going to walk you through step by step how I would go about improving the flow through a manufacturing facility. So how do you create good flow? What are the steps you have to take to accomplish this? Well, I'm going to walk you through a step-by-step approach, which is the approach I would use if I was going into a manufacturing facility and they needed to improve their on-time delivery, their throughput, their cost per unit. In fact, I thought it would be interesting as we go through this to follow the DMAIC process, since we're learning DMAIC as part of this training, and see how the DMAIC would help us with improving flow. Step number one, we need to establish a goal with our team that we are going to produce just in time. This is often a big mental switch for people. They're used to producing in big batches. They're used to scheduling a certain way. So we need to start the project off in the define phase by agreeing as a team that our goal is to do what Toyota and other lean companies do, which is to produce exactly what is needed when it's needed just in time. Another term for this is one-piece flow, or what we call one-by-one production. Next, we have to define the problem. How fast are we currently producing, and how fast do we actually need to go to meet our production numbers and keep our customers happy? Is there a gap? And if so, how big is the gap? Now that we have agreement that we're going to strive to produce things just in time, we need to understand what our takt time is. The word takt is actually not a Japanese word. This is the one German word you're going to learn in a manufacturing environment. Takt means how fast you need to go to meet the customer's demand within the time you have to build the product. So our takt time is a calculation of how many minutes per unit it should take us to produce our units. You can think of takt time as the speed that every workstation and every operator must go to perform their work to get it done on time based on the customer's demand. The equation for takt time is the time available to produce the parts divided by the number of parts the customer has ordered or the demand for the parts. The takt time is actually the beat or the rhythm that you want to dance to, and you want everyone on your team dancing to hit those goals. Now, the goal is to match the rate of production to the rate of consumption. So you don't want to move too fast and hire too many employees and have too much equipment that you can go too fast. And at the same time, of course, you don't want to be too slow and miss your delivery dates. So every operation, every process step needs to have a cycle time that is at or below the takt time. If you do, you'll be able to hit your goals. So what's the calculation for takt time? Let's go through an example together. Let's say we have 7 hours or 420 minutes available to produce this order. Our demand is 1,000 units. If we divide 420 minutes by 1,000 units, we'll get 0.42 minutes per unit. Now, if we want to turn that into a takt time in seconds, we can multiply that by 60 seconds per minute, and that gives us 25.2 seconds per unit. Now, a lot of companies operate on a pitch of 1 hour, a pitch meaning a segment of time in which you need to get a certain amount of work done. So you can take your takt time, which is seconds per unit or minutes per unit, flip it over, and that will give you units per hour or units per minute, which you then multiply by 60 to get units per hour. So you can flip it and operate that way, look at your units per hour, but it's always good to know what your time per unit is so that you can go out and measure each of your processes, gather cycle times, and find out if each process step can actually hit the takt time. Now that we know what our takt time is, we can calculate our performance gap. This is the problem that we need to solve. So we're going to take our takt time, which is our desired average time to complete an order. We're going to subtract the current time to complete an order. That's going to give us a negative gap there if we're slower than our takt time. That's the performance gap that we need to fill in order to improve our on-time delivery and lower our costs. So you can see the example down below. If it's going to take us 3 days to complete 1,000 units and it's currently taking us, if our goal is 3 days and it's currently taking us 5 days, we need a 40% reduction in our lead time and in all the cycle times of our stations so that we can get that order out on time consistently. Once you've calculated your takt time and you know what the numbers you need to hit, go ahead and go back to your project charter, and in the KPI section, just fill out your current throughput and where your target needs to be, which would be your takt time. If you're using the Kaizen idea card, same thing. Just go to the KPI section, put your current throughput or current, minutes per unit or units per hour in the KPI section, and then the target you need to hit, which again is your takt time. And with those few simple steps, you're pretty much done with the defined phase of a good flow project, and you can move right on to the next module where we start to measure the process.